Okay, it's time to start projectiles. We finished conservation of energy and momentum. Time to start projectiles. And you all know what a projectile is. It's any object that's going through the air in more than one direction. So kicking a football up and it coming back down, throwing a baseball and it falling down. Okay, so projectiles are 2D motion, two-dimensional motion. Okay? And there are two different types. There are horizontal projectiles and there are angled projectiles. And so today we're going to look at the horizontal ones. Tomorrow we will get into the angled ones. For a horizontal projectile, you have to start from some height. Because you're going to do exactly what its name implies. You're going to throw it, launch it horizontally. So if you don't, which means totally in the x direction. So if you don't start from some height, then really you're just kicking it along the ground. So here I am on the roof of the building. This is my height. Here's the ground. And I'm going to throw a projectile horizontally, giving it then a Vix. Okay? But it doesn't, and so it has no VIY, no velocity in the y direction. But it does when I first let it go. But it doesn't take very long before gravity begins to work on it. And it does end up having a velocity in the y direction as well. Now the good news about both types of projectiles is that there are no new equations. The equations that we're going to use are going to be equations that we've already seen in kinematics. We're just going to separate them into the x and the y. So the first step is to separate our givens even into the x and the y. Whoops, it's not really 0, it's something. So Vix is going to be some velocity. Okay? VIY is going to be 0. It's not moving initially in the y. AY is going to be 9.81 meters per second squared. It's gravity going down. AX, once I throw this object, there's going to be nothing that's going to affect it in the x direction. We're going to assume no air resistance. There's no big force field over here like a big magnet sucking anything in. AX will always be 0. The height from which you throw it is the delta dy. And how far away it lands, we often call that the range, and that's delta dx, right? In football, in baseball, what's the range of his arm? How far, or her arm, how far can they throw it? And the time that it takes for it to travel all the way out here is the same as the time that it takes to reach the ground. So the time in the two directions are the same. So once you have it in one direction, you have it in the other. And really the time is determined by the y direction, right? If it wasn't for the fact that gravity was pulling it down, this would travel out forever. So our equations then for x are, we're going to have our delta d equation, our wonderful, well-loved, well-used vi delta t plus 1/2 a delta t squared. And in the x direction, it'll be delta dx, Vix, and AX. Now, the second term here is going to go to 0 because there's no AY, but we'll write it down and then cross it out. And in the y direction, it'll be delta dy is equal to VIY delta t plus 1/2 AY delta t squared. And for horizontal projectiles, the VIY will go to 0. But again, write it down, because when we get to angled projectiles, not the same things won't be 0. So we have those two equations we can use. Now we also have our other well-loved equation, VF, we'll put an x here, squared is equal to VIX squared plus 2AX delta dx. And of course in the y direction, VFY squared equals VIY squared plus 2AY delta dy. Okay, boxing this one, it is useful. Take a look at this one though. It's not that useful because AX is 0, which means this term disappears, which means we're left with VFX squared equals VIX squared, or VFX equals VIX, which I think we already knew because AX was 0. So the v's don't change. We don't really need an equation to tell us that. We also have ax is equal to vfx minus vix over delta t, and ay is equal to vfy minus viy over delta t. This one's useful. The viy will go to 0, but it will allow us to find the vfy. This one, not so much. Vfx and vix are the same, so this side is 0 and ax is 0. This one proves that 0 is 0. We might have already known that. Okay, so these are the equations. So all we're going to do is we're going to solve, we're going to list our components, list our givens in the x direction and the y direction, figure out which side to start from. The time will transfer over, and we'll be able to solve. Easy. So let's do an example. So let's suppose my building is 98.1 meters high. Let's suppose I'm throwing an object with a velocity, of course, in the x direction horizontally, 3.2 meters per second. And we're going to ask, how long is it in the air, delta t? How far away did it land, delta dx? And with what speed does it hit the ground, vf? Okay, so it's going to do this. I'm going to separate your givens into x and y. So vix is 3.2 meters per second. VIY is 0. AY, 9.81 meters per second squared down. AX, always 0. Delta dx is one of the things they're asking us to find. Delta dy is 98.1 meters, and that's down. It ends up below where it started, so it's down. We don't know delta t for either. And I don't have room to put the VF in, but it would be here, right? So we're looking for this VF, which means we're going to need VFX and VFY. Okay, but where do I start? Well, if you take a look at your two sets of unknowns, in the y direction, the only thing you don't have is the time. So start there. And you have delta d, vi, and a, so delta dy is equal to viy delta t. 1/2 ay delta t squared. This term goes to 0. Multiply both sides by 2. Divide by a. So 2 times 98.1 meters divided by 9.81 meters per second squared. T squared is going to be 20 seconds squared. So t is going to be 4.4 something. 4.472 seconds. Okay? B, delta dx is equal to vix delta t, 1/2 ax delta t squared, but ax is 0, so this term disappears. Delta dx is equal to 3.2 meters per second times that 4.472 seconds that you just found up here. Multiply them together using your calculator if you want, and you get 14.311 meters. Okay, C. We need VFX and VIX. Well, VFX should be pretty easy because AX is 0, so VFX is just equal to VIX is equal to 3.2 meters per second. VFY, you could use one of two equations. I'd probably use VIY squared plus 2AY delta dy. This goes to 0. VFY squared is equal to 2 times 9.81 meters per second squared times 98.1 meters. Don't forget to take the square root, and when you do, you get 43.872 meters per second. So then once you have that, we might run out of time here. So it looks like this. This is 3.2 meters per second. This is 43.872 meters per second. You're going to square them, add them together, take the square root, and find this theta because it's the same as that one. So VF is going to be 43.988 meters per second at an angle of, which I don't have, let me find it before it goes.